Edexcel A-Level Maths, Pure Paper 2, Summer 2018, Question 3. So we have the statement that m and n are irrational numbers, where m is not equal to n, then mn is also irrational. We want to disprove this statement by means of a counterexample. Now there are many examples you can use for this. One I'm going to use is that we're going to let m equal root 3 and n equal root 12. So these are both the square roots of numbers which aren't themselves square numbers, hence they must both be irrational. But if we multiply them together, then mn is equal to root 3 times root 12, which is root 36, which is equal to 6. So 6 is rational, and this statement is untrue. So for part B, we want to sketch the graph of y equals modulus x plus 3. So for positive values of x, this is going to be the same as y equals x plus 3. So we've got a straight line with a gradient of 1 going through the y-axis at 3. Now if you think of what happens when we go into negative values of x, we're taking the modulus of this x. So it's going to end up being the same answer as if we just took a positive x. Hence the graph is going to go back up to the left as a reflection of our first line in the y-axis, looking like that. So we now want to explain why the modulus of x plus 3 is larger than or equal to the modulus of x plus 3 for all real values of x. We can do this by drawing a graph. So on this graph I've got our graph from above, y equals modulus x plus 3 in blue, and then in black I've added on the modulus of x plus 3. Now again we can see that for positive values of x it's exactly the same line as x plus 3. But for negative values of x between negative 3 and 0, because x plus 3 is still positive, our graph is still going to be positive, hence it's looking the same. So we've got the straight line going down through 3 on the y-axis, all the way down to negative 3 on the x-axis. At this point, as x gets smaller than negative 3, x plus 3 would become negative, but we're taking the modulus, so it starts going back up again as a reflection of the right-hand side in the line x equals minus 3. Now we can see from this graph that for all values of x, our blue line is either equal or above the black line. Hence, modulus of x plus 3 must be larger than or equal to the modulus of x plus 3 for all real values of x. If you've enjoyed this video, don't forget to subscribe to the Doing Maths channel or check out some more of my videos by clicking on the links here.